Welcome to Let's Talk About Data, the series where we break down the tools and concepts driving the data revolution. If you've ever touched data science, machine learning, or even serious number crunching in Python, you've definitely encountered NumPy. But what is it? Why is it everywhere? In this episode, we're going to pull back the curtain and uncover what NumPy is, why it's so critical to modern computing, and how this single library revolutionized numerical computing in Python. Let's dive into the foundation. Simply put, NumPy stands for Numerical Python. It's the fundamental package for scientific computing with Python. And when we say fundamental, we mean it in the most literal sense. It's the very bedrock. NumPy provides the core data structures and operations that other major Python scientific libraries are built upon. Think of libraries like SciPy, which handles advanced mathematical functions, or MATLAB, the go-to plotting library. They all use NumPy arrays under the hood. You can't effectively use the broader scientific Python ecosystem without it. The need for NumPy arose from a desire to make Python a first-class language for high-performance numerical computation. Before NumPy, array computing in Python was fragmented. In 2005, Travis Oliphant merged features from two older array processing packages, Numeric and ndarray, to create what we now know as NumPy. This was a massive shift. Historically, specialized software like MATLAB dominated numerical work. NumPy effectively emerged as the open-source alternative to MATLAB, bringing that same high-level mathematical functionality into the widely accessible, general-purpose world of Python. It meant no more expensive licenses, faster development through a vibrant open-source community, and the ability to integrate heavy-duty computation directly into general application development, not just isolated mathematical environments. At the heart of everything NumPy does is a single, powerful concept, the ndarray. That N stands for n-dimensional and array refers to a table of elements, all of the same type. This is the central object you'll work with almost exclusively. Think of a 1D array as a simple list or a mathematical vector. It's a single dimension of elements. A 2D array is what most people visualize when they think of data, a matrix with rows and columns. This is perfect for storing tables of data, like a spreadsheet or an image where rows are pixel rows and columns are pixel columns. And where NumPy truly excels is going beyond 2 dimensions. A 3D array could represent a video, where the third dimension is time or color channel data, or it could represent a stack of images. In modern machine learning, these higher dimensional arrays are often called tensors. Think of the ndarray as your mathematical canvas. Unlike a standard Python list, which can hold elements of different types and is slow for large operations, the ndarray is designed for homogeneity and speed. All of its elements are of the exact same data type, and they are stored efficiently in a contiguous block of memory. This structure is what allows NumPy to perform operations on millions of data points in a fraction of a second. So, if the ndarray is so foundational, where is it actually being used? The short answer, everywhere. NumPy is the necessary first step for almost all advanced computation in Python. At the base, we have NumPy providing the array object. Just above it are libraries like Pandas, which adds labeled access to NumPy arrays to create data frames, and SciPy for more advanced scientific functions. And at the peak, you have the libraries that are powering the future, Scikit-learn for machine learning, and deep learning frameworks like TensorFlow and Pi. Torch. Every single data point, every image, every calculated weight in a neural network is, fundamentally, and ndarray. Whether you're processing a massive financial dataset, running complex physics simulations for engineering, or training the next generation of generative AI models, you are relying on the fast, stable array operations that only NumPy can provide. It's the silent powerhouse behind almost all modern data innovation. Let's quickly recap what we've covered. NumPy is the Numerical Python library. Its core is the ndarray, an efficient, homogeneous data structure that handles vectors, matrices, and tensors of any dimension. And finally, NumPy is the bedrock of numerical computing in Python, supporting the entire scientific and machine learning ecosystem. We've established what NumPy is, but you might be wondering, why not just use regular Python lists? That's a great question, and it's what we'll answer next time. In the next episode, we'll dive into the performance difference, exploring why NumPy is hundreds of times faster and smarter than pure Python for mathematical operations. Don't forget to like and subscribe so you don't miss that deep dive. Thanks for watching, and we'll talk about data again soon.